After you have decided what your system is, you have to describe your system by using properties, states, and processes. So for example, what is a property? For example, you have an engine. How do you describe this engine? For example, the length, the weight, the mass, the volume, those are all properties you can use to describe your system to other people. Okay, so we're going to start from properties first. So what is the definition of a property? Property is a macroscopic macroscopic characteristic of a system, such as, just like we said before, the mass, volume, temperature, to which a numerical value can be assigned at a given time without knowledge of the previous behavior. Okay, so here we have two key things I want to point out. First of all, you must have a numerical value. So for example, what is the mass of this engine? You must have a number for it. What is the volume of this engine? You must have a number for it. So the first key in this definition is you must have a numerical value. Okay, the second key in this definition is without the knowledge of the previous behavior. So for example, if you want to measure the mass of the engine, do you have to know what happened to this engine before the moment you put it on a scale? No, you don't. You can find out the mass of the engine at any given time without knowing what happened to this engine before. Another example, temperature. Temperature is a property. So for example, you want to measure the temperature of the house, the inside temperature of your house. Do you have to know what happened to the house before? Or can you just measure the temperature at any given time without knowing what happened before? You can. So, in summary, you have two key things in a definition of a property. The first one is you have to have a numerical value. The second one is you don't have to know what happened before in order to measure the property. Okay, so that's the first one, property. You have to use properties to describe your system. The second thing you need in order for you to describe your system is states. What are states? A state refers to the condition of a system as described by its properties. So for example, if I tell you I have some H2O, H2O is just water, right? So if I tell you I have some H2O under 1 atmosphere pressure, and I also tell you the temperature of this H2O, temperature is a property. I tell you the temperature of this water is at 0, oh, let's do -10, -10 Celsius. What will be the phase of this H2O? From this number, you can easily tell it must be ice because it's below 0 Celsius. What if I change the temperature to 20 Celsius? If I change temperature to 20 Celsius, you must know the state of this H2O must be liquid water because it's above 0 Celsius, but below 100 Celsius. And then what if I tell you the temperature of the H2O is 200 Celsius? What will be the state? It must be vapor because 200 Celsius is above 100 Celsius, which is the boiling point. So you do not have any liquid anymore, but only vapor. Okay, so that's the second thing you need, the state, when you describe your system. The third thing you need when you describe your system is a process. What is a process? Process is a transformation from one state to another. For example, you have some ice and then you start to heat it up. Add heat into the ice. What's going to happen? The ice will melt and it will become water. So there's a transformation from ice to liquid water, from one state to another. This is called a process. Okay, and the next one is steady state. Steady state. What is steady state? Steady state means none of its properties change over time. Okay, so it's pretty easy to understand. Nothing changes. If nothing changes, then you can call it steady state. However, here I want you to remember no change over what? Because in reality, we live in a four-dimensional world. We have an x direction, y direction, and a z direction, and then the last dimension is time. As long as your system doesn't change over time, then you can call it steady state. If your system changes over x direction, but it doesn't change over time, you can still call it steady state. The only requirement is no change over time. Okay, so now how do we write steady state in mathematics? We can translate this sentence into mathematics. Change of any property. I use partial. Partial any property over partial time must be equal to what is the solution? Change, the numerator means the change of the property. The denominator means time. So the change over time must be 0 because that's the definition of steady state. Steady state says there's no change over time. The reason why we use partial instead of differential is because, like we said, in the real world you have four dimensions, x, y, z, and t. So t is only one out of the four variables. That's why we use partial instead of differential. Okay, and then next one, we have two categories of properties. The first one is called extensive. The second one is called intensive. What's the difference between those two? Extensive versus intensive. Extensive properties are additive, while intensive properties are non-additive. Okay, let's think of a few examples for each one of them. Let's start from extensive properties, which are additive. Additive means you can perform addition. So for example, you have object A, which weighs 10 kilograms, and then you have object B, which weighs 20 kilogram. And now you put them together. What is the new weight? What is the new mass of the combined two objects? Is 10 kilogram plus 20 kilogram, which is 30 kilogram. So can you perform addition for mass? Yes, you can. So mass is additive. So mass is an extensive property. The first example is mass. The next one, can you think of another example that is additive? What about volume? You have object A, which has a volume of 1 liter, and then object B, which has a volume of 2 liter, and then you put them together. What will be the new volume? 1 plus 2, 3 volume, 3 liters. So yes, you can. You can perform addition for volume. So volume is another extensive property. Let's think of two examples for intensive properties where you cannot perform addition. What kind of property cannot be added? What about temperature? So for example, you have object A, which is at temperature 100 Celsius, and then you have object B, which is also at 100 Celsius. And now you put those two objects together. What will be the new temperature? Will it be 100 plus 100, which is 200 Celsius? No, the temperature is not 200 Celsius. So the temperature will still be 100 Celsius for the two combined objects. So you cannot perform addition for temperature, non-additive. Temperature is a non-additive property, in other words, intensive. Okay, let's think of another example for intensive properties. Pressure. Okay, so now let's say the pressure of the air inside your house is 1 atm, and then the pressure of the air outside of your house is also 1 atm. And now you break the wall, so the inside air will mix up with the outside air. What will be the new pressure? Will the new pressure be 1 plus 1, 2 atm? No, the pressure will still be 1 atm. So you cannot perform addition for pressure. So pressure is another example for intensive properties. Okay, what are the common properties we're going to use? Measuring properties. Before we go to that, we need to clarify the units we use in this class. In this class, we stick to SI units because SI units are usually the easiest ones to use. So for mass, the unit we're going to use is kilogram. And then for length, the unit we're going to use is meter. And for time, the unit we're going to use is seconds. And then for force, the unit we're going to use is Newton. And then for energy, the unit we're going to use is joule.